All right. This is intended to be I was going to say short video, but I don't know how short it's going to be. But a video kind of looking a little bit more in depth into dimensioning and trying to demonstrate the correct way to think about it and to go about it, to have kind of a workflow. I've been, obviously the projects that you're working on now with Module 3 involve drawing and dimensioning. And these are probably going to be the more difficult projects that you're going to be working on. And you're probably going to, some of you at least, are going to get some low grades because you're going to approach the drawing and dimensioning especially, with no clear understanding of what you're really trying to accomplish, and how best to go through that. Now, I've tried to lay this out with the series of videos that are already included in Canvas. And some of you are going to watch that, and I think that's going to help greatly. Some of you are not going to watch those videos, and then you're going to be surprised by the grades that you get on the dimensioning. So I'm going to put out one more video or a series of videos here that are going to try to walk you through some of the thinking involved in creating a drawing and a series of drawings and dimensions. And so what I'm going to use is I'm going to use the caster assembly. Okay. And the reason I'm using the caster assembly is because one huge problem that all dimensioning and even drawing, but mostly dimensioning exercises and practice has, is that they do not start from the point of view of the assembly. Okay. All parts live in an assembly. And in order to properly dimension a part, an individual part, you must understand where it fits, where it sits, where it lives in the assembly. If you don't understand this, then your dimensioning is going to be wrong right from the start. And incorrect dimensioning is going to make it very difficult or impossible to do correct tolerancing, that is, dimensional tolerancing and geometric tolerancing. It's going to make the part overly expensive to manufacture, and it might make it impossible to manufacture. So it's absolutely critical that you approach an individual part drawing with an understanding of where it fits in the assembly. And so that's why I'm choosing the caster assembly to start with, because it's an assembly that we've already done, that you've already done. And so you probably have a good idea about this. Now, this is not one of your assignments to do individual part drawings of the assembly part, of the caster assembly parts, but I'm going to use it as a starting off point for doing some examples. Okay, so I have my caster assembly here, all right, and it doesn't matter whether it has joints, because joints are not going to play a role in the drawing of it. Okay, and I'm not going to do an assembly drawing. I'm going to do individual part drawings. Okay, and I'm going to start with the top plate. Okay, an individual part drawing for the top plate. Now, bear in mind that if we were actually going to manufacture this caster assembly, we would have individual part drawings, what we call detail drawings of each one of these components. We would have a detailed drawing of the top plate, a detailed drawing of the axle support, a detailed drawing of the wheel, a detailed drawing of the bushings, a detailed drawing of the axle, right? We wouldn't have a detailed drawing of the nut, bolt, and washer, because those are purchased parts. Okay. So we would, and then we would also have a drawing of the assembly showing everything. So that's called a working drawing set, when you have all those drawings together so that you can manufacture each part and assemble them. That's called a working drawing set. And what's interesting, or at least I find interesting, is that everything that you buy, every last thing, whether it's a pair of headphones, whether it's a computer mouse, whether it's a car, whether it's a iPad, a stapler, whatever, they somewhere there exists a working drawing set of that object. All right. That assembly. Right. So I just find that very interesting that there's all these working drawing sets of everything. So, all right. So we're going to do a series of drawings, and, we're going to start with the top plate. All right. So, we're going to go to drawing, and from a design, and then here, we're not going to do a full assembly, right? We're going to select the part, and I'm going to select the top plate. All right. And I'm going to not do ISO. That's the metric standard or the European standard. I'm going to stick with ASME. The units are millimeters, and I'll stick with a B-size drawing sheet. I think that's going to fit okay. Understand that we can change this if we need to. If we get something wrong here, like we need to go to C, we can change that. So I'm going to go okay. All right, and we'll see what comes in here. Takes a little bit of time. There we go. Okay, so now we have we're going to be placing our base view here. Now let me stop, because I received a few emails over the last couple of days, kind of showing some confusion about this. Right now, what I'm looking at, this base view right now is, and let me go over here to the right, the front view. Okay, now, what front view is that? That is Fusion's front view. That has nothing at all to do, necessarily, with the orthographic view that I choose as my front view. It may be my front view, or it may be my top view. Okay, but understand that the word front here is purely derived from this model and front on the view cube. So that's completely arbitrary. All right, that's completely arbitrary. Whoops, I made it go away. All right, so whoops, and now I've messed everything up. So let me go back to let's go back here. All right, I'm going to have to close this because I messed everything up. All right, so let's go back to this. All right, and we're going to select, and we'll do our top plate, and we'll do ASME. Sometimes it doesn't work out when I jump out of there for a second. All right, so now I got my view. Now, I need to understand what view I want to have as my front view. And remember that our front view should be the most descriptive view, right? It's obviously not going to fully describe the object. That's not possible, generally speaking, with a three-dimensional object, unless it's a very simple object. So I want my front view to be the most descriptive. I also know that I want this to be 1-to-1 because that's kind of small right there. Okay, so that's better. Now, I also want it to be in a normal or natural orientation. So, I think what I'm going to end up doing is I think I'm going to use the top view as my base view, and I can choose either this top view or this top view. There's subtle differences, but I'm not going to go into what the differences are right now because it really doesn't matter. So I'm going to use this. I'm going to call this my top view or my front view. It really doesn't matter. All right. But this is going to be my most important view. So I put that right in there. I say, okay, so far so good. And then I'm going to generate my projected view from this. Okay. All right. Now, there's a few things that I can do here. When I'm looking at this, I see that I have, everything is good. It's a very simple part. I only need two views for this, right? For simple parts like this that are more or less what we call 2.5 dimensional, in that they have a uniform thickness, aside from the little step here, it's basically uniform thickness. One thing that I could do, I see here, is notice that this hole on the left and on the right, these holes are hidden. Now, I might want to show these as a section, show this as a section view so that I can expose those holes. I don't really think that's a big issue right now because this part is very simple. So I'm not going to worry about that. Okay. So let me go ahead and put in my center marks here. And I'm going to show you now. Notice I put in the center mark. Notice I picked the outer arc right here and it put the little plus. All right. And now I'm going to go back and I'm going to pick the circle and notice it puts the mark in there. Okay. So that's something that we want to be aware of. I think I spoke about that in the other videos. We don't want the plus, when the mark will do. And actually, I want to stretch this out. Now I'm going to zoom in here. I'm going to stretch this out like so. All right. Just a little bit beyond. Now, in the CAD standard, we talk about the extension beyond the edge that this is supposed to have. It should be 0.312, or I think 6 millimeters, but we're not going to worry about that. That's really something that we can do in AutoCAD. Right here in Fusion, we can't really keep track of that distance real easily. Okay, so I'm going to put in the rest of these, making sure to pick all these circles. And yeah, you got to kind of pull this out a little bit here and a little bit there. So it's a little bit tedious, but you know, making the drawings correct is sometimes a bit tedious, especially when the software doesn't kind of conform to the standards. And we want to have center lines through here. And you might be thinking, wait, center lines through the hidden circle? Yes, absolutely. Okay, center lines through a hidden circle. Now, I want to make use of the symmetry of this part, because when I go back to, and I'm going to save this because I don't want it to mess up like it did before. So I'll do caster assembly, and then I'll call this top plate. All right, and there we go. Now I'm going to go back to the caster assembly because now I want to start to understand where this part lives. So in this design, right, one of the main features of the top plate and the whole design in general is its symmetry, right? It's important for the operation of this that the axle supports are balanced, right? You can imagine that this is going to be hanging from something or you know, supporting some weight. And if there's an imbalance in this, with the force resting on the top plate, then it might not be ideal. It might cause the wheel to wear on one side. It might cause the bushings to fail. It might cause the axle to bend. So balance, symmetry is an important thing. So how can I build symmetry into my design through dimensioning? Okay, well, I want to make use of that symmetry. And what I'm going to do is I'm going to say that the part is symmetrical by putting a center line through that. Okay. Now, this is not a cylindrical feature, right? It's not a hole. It's not a cylinder, right? So is putting a center line through that allowed? Absolutely. Yes. And in fact, it's required when we want to, when we want our design intent to clearly say symmetry is part of our design. Okay. Now I can also add another one down here, which I'll do. I'll pick these outside lines right there, and then I'm going to pull this out just a little bit. Right. Whoops. I think I moved it a little bit. Let me delete that. Let me start again. I should say at this point, the drawing aspect of Fusion is its weakest part. Okay, so if you're going to complain about the drawing part of Fusion, I'll give you the email to Autodesk and to the Fusion 360 design team, because I've emailed them plenty of times, and I think it's important that they understand that to make a really good product, and they have a product that's 90% there, they need the drawing aspect to really kind of get there. All right, so now how can I make use of that symmetry? Well, it's very straightforward. I'm going to dimension across, let's just do it from, well, I'll do it from here to here, right? So there we go. All right, now understand that that 136 also defines the distance from one side to the midpoint, okay? Which is exactly half of 136. Now, the important thing here is to understand, to really get this, you need to have the drawing, the dimensions, include tolerances, okay? And to understand that parts are going to be manufactured that are imperfect, okay? So if we're approaching this from a mathematical point of view, right, half of 136 is what? Oh geez, I shouldn't have done that. Half of 36 is 18, so 15, 18, 68, right? 68. But in reality, this would have to be a tolerance dimension. And so we would be able to define the center of this only after we made the part. All right. And that's an important distinction. All right. So, so when we have a dimension span across the center line, it's the same thing as dimensioning across a diameter. All right. So that's that. All right. Now, to locate the holes. Now here, let's see what I can do here. I could dimension across here. Right? And I'll move this out a little bit because it just is a little bit too close. Whoops. There we go. And maybe I'll jog this to the side. There we go. All right, so it looks. Now, is that really the best functional way to locate those holes? Well, I think it is, right? I think it is, but we want to make sure that we locate this surface here, all right, from the hole. Now let me go back here to kind of talk about why. Let's look at the front view of this, okay? Now you'll see that one of the critical aspects of the location of the hole in the top plate is the distance from the center of the hole to this edge right here in the top plate, because that's exactly where the axle support fits. So that's what we call a mating condition, right? We have two parts, two features that are going to mate together. We have, in essence, in the top plate, the hole, and then the positive feature is the axle support that goes in that hole or that cavity, okay? So I want to make sure I dimension that, right? And the way that I'm going to dimension it is in the front view here, from here to here. All right, and I'm going to do the same thing over here. Oops. There we go. Okay. Now, technically speaking, I do not need to put the other 26 in there because the center line indicates symmetry, which means that what happens on one side would be identical to the other. All right, so I'm going to get rid of this. I just wanted to put that there to show you, you know, what it is and to talk about using the line of symmetry again. Using a line of symmetry for design intent is a great help, right? It really simplifies things. Now, the only problem that I have with this is if I'm being really picky, I'm dimensioning to a hidden feature right here. And that's kind of a rule breaker, right? So I'm not going to break the rules, right? I'm going to get rid of this drawing and all this good stuff that I did. And I'm going to do what? I'm going to generate a section view, right? And I'm going to generate it right here and go straight across and put that right there, okay? So sometimes you're going to be adjusting, and I don't need this. Sometimes you're going to be adjusting your drawings as you go through them. Right? You're going to get to a point where you say, hey, wait, you know, I don't think I like this view, or I don't think I need this view, or this view needs to change, or I need another view. You know, don't be afraid to chop and change and kind of prune and adjust your drawings. You're really going to need to do that. So let me go back in and put this center mark in there, and that center mark in there, like that. And then I'll put this linear dimension back in there. Oh, and you know what I forgot is this center mark through that. Now, you might argue, and there would probably be some that would. Why does that keep doing that? And some that would argue, you know, it's not really a big deal. You could have left that in there. Yeah, you're probably right. But I would rather, especially in class, I would rather stick to the rules to show you that there's a way around that. That there's a way to satisfy that. Okay. So we got that in there. We need, of course, width dimensions, right? So remember, we're going to use our two-step process. Okay. I guess I should go back here. So we have the holes. Let's go ahead and dimension the holes. We have 4 holes, so I'm going to swing this down here. Okay. And we want to adjust that note to say 4 times. Right, like that. Okay. So we got those 4 holes in there. This is a little bit, let's get the overall, right? Overall dimensions are also good. So we got the overall length. Let's get the overall depth. We'll pull that right out there. That looks good. And the overall thickness. Now there's going to be some thicknesses that are a little bit different. Okay. So we'll dimension this right there. But one of the questions is going to be, how do we handle this step? And let's go back to our main object again, our main assembly, and to see what is functional and what is not functional. Okay, so I think it's clear to say that this step in is not functional. That is to say, its function is limited, and the depth of this is immaterial. It's not really critical. Why do we have that little notch in there? Well, it's to provide a surface here and a surface here so that we have maybe 2 flat surfaces, okay, to give some kind of relief. Maybe it's going to be on a rail, the left and right rail, and there's nothing in the middle, or there's something in the middle that would, you know, cause this to sit wrong. But on the other hand, the depth here, where the axle support nestles right in there, is functional. So we do want to make sure that that depth is carried through, is dimensioned. So we want to understand, when we dimension, we want to clearly dimension things that matter. Okay, dimension things that matter. So here, what matters, as I just said, is this, right? Now I'm going to fix this, right? I'll pull this out here. I'll do this in 2 steps. I'll pull this out here, and then I'm going to move, I'm going to move that across right there, right? Oh, that's not. Is it not going to let me do that? There. I guess it's not going to let me do that. All right, so we'll fix that. We don't want that. It looks like double vision, so we'll just pull that out right there. Okay, so that's fine. All right, so now we have that in there. We have this explicitly dimensioned. All right. Do we really need the 12? No. As a matter of fact, we don't, right? It might be better to have an overall view so that we know how much to cut off. So now I'm going to say, you know what? Maybe that's not the best thing. Let me move this back in here. Maybe the best thing would be to have an overall dimension, right? You have to also think from the point of view of manufacturing. We're going to start with a sheet of whatever this is, steel. And we're going to cut this away and cut this away. So having that dimension in there and having the overall dimension is going to help us get started. All right. And finally, we can't forget this, right? So we do have to say how far this is going to cut in, right? So we put it in there, and please don't leave it like that, right? We're going to pull that out like that. Now, I suppose you could leave it like that, right? Would it be better to pull this out here? Whoops. That's not the one I wanted. Would it be better to do this right there and pull it out here? So is it better to have an arrow inside the object or an extension line to come across the object? You know, I don't know. I guess in this case, I don't really like the look of this cutting across here. So I'm gonna get rid of that one. All right, we'll leave the 4 in there like that. Okay. So I have my thickness dimensioned with all my steps. Right, and I've explicitly dimensioned this 4. That was important. I have the 26, and of course the mirror image here because of the line of symmetry is going to be the same. I have this width. Now I need to dimension. I'm going to pull this out because I know that I'm going to need room in there. I need to dimension the distance between these two holes. And I'll pull that down there like that. Make it look nice and neat. Now I don't know why that exclamation point got in there. I think I know why. Let's put this in again, because I went from the cutting plane line. So let's go right there to there. There we go. Okay. Now, is there anything else that I'm missing? Okay. Yeah, there's a couple of dimensions here that I'm missing. All right. So I'm missing the length of this foot. Now you can, again, we have a choice. We can dimension, I'll show both of them. We could dimension here, or we could dimension, let's do it on this side, here to here. All right. From a functional point of view, I think it is clear, since this middle gap is not really functional, but the foot pad here is, the 44 is more appropriate than the 48. Okay, so we'll put the 44 on there, and we don't need to put a 44 over here because of the same reason why we have 126 here and not one over there on the right-hand side. And then the last thing we need to do is we need to do the radii on the outside. Now here, this is a little bit tricky to see. Okay, so let me go ahead and put this dimension in here, right? And of course, there's 4 of these, right? So we got to go in here and say 4x and go like that. Now this is wrong, all right? This radius, these 4 radii dimension in here, that they're wrong. You might be thinking, well, why is that wrong? That's a radius on a curve. We need that radius on a curve. Well, we've over-dimensioned this with this radius. Because, look, we got the 136, we got the 112, we got 12 right there, and we have 12 right there. So we have no, I guess we have no area for like an open space. We've over-dimensioned it. All right. So when we have every dimension accounted for in here, then that's over-dimensioned. So we need some opening here. So how are we gonna deal with that opening? All right. The 136 is pretty important. right? That's the overall size of the object, all right? It has to do with the distance of the axle support. It has to do with the length of the axle, okay? The 112, that's also pretty important, right? Because it tells us the distance from the center out to the hole, right? Half of 112, which would be, what is that? 61, right? So from the center out to the hole, and then from the hole back to this edge. That's kind of an important chain. That's an important chain. So to really alleviate this issue, the outside curves here, these radii are not, again, they're not really functional. They're for appearance only. Okay. So what I'm going to do is I'm going to put these in parentheses, right? And parentheses means that they're reference dimensions. That means that they're not going to have tolerances, okay? So it really tells the machinist that, you know, these are dimensions that are not super critical. And that's how we avoid this over-dimensioning. Notice that it would also be over-dimensioned on the depth as well. All right. So that's the drawing completed. Okay. Now I'm not going to go through and put the notes. You've already seen my, my videos and the notes that we would put in there. There's, the notes here are pretty straightforward. There's no fillets and rounds on this part, so we don't have to put that in there. Do I have everything dimensioned? Holes, yes. Length, width, and thickness, yes. The notch here and the notch here, yes. This location for this surface, yes. The location of the hole, yes. So that is completed, and I'm going to save that. All right. And in the next video, I'm going to have a look at the axle support. Okay.